Hi, my name is Casey Watson and I'm going to explain to you Newton's law of motion. The first law of motion is an object at rest will stay at rest until acted on by an unbalanced force. Also, an object in motion will stay in motion unless acted on by an unbalanced force. This law is also called the law of inertia. The first law means if nothing is happening to you and nothing does happen, you will never go anywhere. But if you're going to a specific direction, unless something happens to you, you will always go in that direction. In my first demonstration, I will show you this law with a roller skate and a cup of peanut butter. I am putting the cup of peanut butter on top of the roller skate. Notice that the roller skate and the peanut butter has not moved and will not move unless an unbalanced force acts upon it. I will be that force. Next, I will demonstrate that the roller skate and the peanut butter cup will continue to move the same direction and speed until acted upon an unbalanced force. Notice that the roller skate hit the door and the cup of peanut butter continued to move forward. That is because the cup of peanut butter continued to move forward without the roller skate until an unbalanced force acted upon it. 2. Which was the door. This example is the same as riding in a car. If you are moving in a car going in a straight line, you will continue to move in that straight line until acted upon by an unbalanced force. If you are not wearing a seatbelt, if the car were to suddenly stop or to get in an accident, your body will continue to move forward until an unbalanced force acts against your body, which would be the steering wheel, dashboard, seat, or something else. It is important to wear a seatbelt, which would be an unbalanced force that will protect you from injury in case of an accident. Newton's second law of motion states that the force of an object is equal to its mass times its acceleration. The acceleration of an object depends not only on how hard you push on it, but also on how much the object resists being pulled. It also means how fast an object moves after it is pushed depends on the force of a push and the mass of an object. In this demonstration, I will use the example of trying to push the chair. It is hard for my brother to push the chair alone because the chair has more mass than he does. However, if I help my brother push the chair, we can travel a lot further and a lot faster because we have more mass than the chair. Another example is the force applied to a cement block will not have the same effect as the same force applied to a shoe. A cement block resists the acceleration much more than a shoe does because it has more inertia or mass. Newton's third law of motion states that every action has an equal and opposite reaction. As you can see, I am pushing against my brother just as much as he is pushing against me, and we are both exerting the same force. The action and reaction are happening at the same exact time. Similarly, I am pushing against the refrigerator as much as it's pushing against me. Another example of third law would be how a fish swims in water. As a fish is pushing the water backwards, the water is pushing the fish forward, and that is how a fish can move in water. I hope these demonstrations have helped to explain Newton's law of motion. Thank you.